All right, so we are continuing our problems on entropy and free energy and also enthalpy. So one of the problem is you can be given entropies of specific species in a chemical reaction and also enthalpies of specific species in a chemical reaction. Like for this chemical reaction, we have sulfur dioxide, then we have oxygen, then we have sulfur trioxide. So you can be given entropies and enthalpies of these species to determine the change in free energy of this reaction. So here you are given a table with entropy of sulfur dioxide and enthalpy of sulfur dioxide. The same thing for oxygen and sulfur trioxide. So if you are given a condition of 25 degrees Celsius, determine whether this reaction is spontaneous or not. So what you want to do first is to look at this equation as given here. So for an equation like that one, the first thing you need to know is that the change in enthalpy of this reaction is given by the sum of all the enthalpies of products minus the sum of all the enthalpies of reactants. So always products minus reactants. So what do we mean? Here we mean the enthalpy, that is this part. We mean the enthalpy delta H of sulfur trioxide minus parentheses here because we have to put the reactants together minus the enthalpy of sulfur dioxide plus half because we have half here. So plus half the enthalpy of oxygen. So I'm going to put these ones in parentheses. So the enthalpy of sulfur dioxide or sulfur trioxide is negative 395.7. So remember, this is given in kilojoules per mole. So this one minus, so you put the parentheses here. Don't forget the parentheses. The enthalpy of sulfur dioxide is minus 296.8 kilojoules. This one plus the enthalpy of oxygen, which is 0. When you add these, you are going to get the enthalpy of, let me see, did I miss something? All right, so you are going to get the enthalpy of minus 98.7 kilojoules per per mole. Now, another thing is what you want to do with this is you want to change it to joules per mole, especially if you want to use it in this equation. So this is equal to negative 98700 joules per mole. So this is our answer. Now, the second part, you have found at this point, you have found this part. Now you need to find this part, delta S. I'll keep this one to avoid confusion, this side. So I will say that delta S of reaction is also given by the delta S products minus the delta S reactants. So in this case, we are going to have delta S of sulfur trioxide minus, in parentheses here, delta S sulfur dioxide plus delta S of oxygen. In terms of numbers, now we are using this part. So we see that this is for sulfur trioxide, which is 256.8. And remember, the units are joules per mole per Kelvin. This one minus, for sulfur dioxide, it is 248.2 joules mole per Kelvin, plus the delta S of oxygen. Now, we know that this is half. So, plus half delta S of oxygen. So, it will be half times the delta S of oxygen, which is 205.2. Now, when you do the math there, let me just all right. So I'm going to do the calculation again just to be sure. So I have 256.8 minus parentheses 248.2 plus 0.5 times 205.2. So when you calculate that, you find that the change in entropy of this is negative 94.0. Now the units are joules, then mole, then K. So at this point in time, we have the entropy part, and we already know our temperature. So we can say, all right, we have found the entropy, we have found the enthalpy. Now we are going to determine our delta G. We know that delta G is given by delta H reaction minus T delta S, which in this case is negative 98700 joule per mole minus our T is 298 Kelvin. Then this one times our entropy, which is minus 94.0 joule more K. So the Kelvin here will cancel with the Kelvin, and we are going to have joule per mole as our units. So that gives us negative 70688 joules per mole. So usually you want your final answer to be in kilojoules per mole. So it will be 70.69 kilojoules per mole. So that's how we determine the change in free energy of this substance. So first, determine the change, the delta S reaction, and then determine delta H reaction, and then plug them in this equation to get delta G. So I think what I'm gonna do is I'll go back. I think I skipped a certain problem. That would be our last problem. So I'll go back to find that problem. Which is this problem? So we needed to solve this problem before solving the next problem, but really don't worry much about it. So we have a chemical reaction here, given here. Our aim is to calculate the standard entropy change in this reaction. So as with the previous reaction, here we are not going to look at delta H. We are just focusing on delta S. So for this reaction, to solve this reaction, as usual, you are going to say delta S reaction is given by the sum of delta S products minus the sum of delta S reactants. So always. So in this case, the product, we have 4 delta S of NO plus, so we'll put the products together, 6 delta S of H2O. So don't forget the coefficients. This one minus 4 delta S of NH3 plus 5 delta S of O2. So that's how we are getting the sum. And we are given all the deltas in this table. So we are going to start plugging in the numbers. So this is 4 times, and the delta S of NO is this one. 4 times 2, 10.8 plus 6. The delta S of water is 188.8. So we have covered the products. So these products minus now 4, the delta S of NH3 is given here, 192.8 plus 5. The delta S of oxygen is given as 205.2. So when we add these two deltas, we find that our answer is 178.8 joules per mole. So this is how we solve our problem when given a reaction equation and we are given entropies for individual species in that reaction equation. And the problem that we solved at the beginning of this video is just a complex part of this simpler problem. So just make sure that you go over this video assignment and be ready to solve these problems in class. Thank you.